as I say, my name's Phil Edwards, Solutions Architect. I'm going to take you through what it means to control and manage costs in Amazon Web Services today. So we're going to talk a little bit about cloud financial management, which is more about how you might approach things from your organization's perspective. Then how AWS help you in realizing that value and saving cost. Talk about the visibility into cost in AWS. I've got quite a long section on how some of the technical optimizations work. We will be distributing the slides afterwards, so if I go through some of those slides a little bit quicker, just in the interest of time, you will be able to refer to them at a later date. And then I'm going to summarize and show you the AWS console, and I'm going to show you particularly how to configure an AWS budget, because I think that's one of the most powerful things you can do in the AWS console to control your costs. So starting with cloud financial management, we kind of approach this from a see, save, plan and run perspective. So firstly, the C, being able to measure usage of cloud and have that accountability regarding which accounts are using what services. The save piece is obviously about cost optimization, so configuring your use of cloud so it's the most optimal based on your demand for those services at any point in time. The ability to plan and forecast services, so we have features in the console that allow you to forecast costs. You can actually set budgets based on those forecasts as well. And then the run piece is, how you do cloud financial operations over a period of time. So the measurement and accountability piece is things like, setting an account structure. So we're going to talk about this in more depth further on in the slides. But you might want to, for instance, make use of something called AWS organizations. AWS organizations allows you to impose your organization structure onto AWS, an AWS account structure, and then control that structure with policies. It's things like tagging. So, we make extensive use of tagging from a cost perspective. So you can see the quote underneath from Kaplan. They tag all their instances on AWS, and that allows them to look at specific costs and, understand the resource associated with any particular application. It gives them a very granular view on how they are spending in AWS on a project by project or individual by individual basis. It's also about doing things like providing a showback mechanism to business units or departments within your university that can either be showback or chargeback. Again, I'm going to show you a little bit of that in the console later. The cost optimization, which we're going to touch on at length. It's a cloud fundamental principle that we match the capacity that you're using at any point in time with the demand for infrastructure, with the demand for some of our application services. So there's this very kind of cloudy concept of matching at any point in time. So you don't have this concept of fixed capacity. You tend to use the right pricing model for any particular workload. So some workloads will lend themselves to more cost-effective cost models, and some workloads will want flexibility, perhaps of a higher cost model, but with the flexibility that brings. It's key to implement processes to try and identify any resource wastage in your AWS account as well. So I'm going to talk about something, and I can even show this later on, called Trusted Advisor. Trusted Advisor is a service within AWS which allows you to identify where you have, for instance, EC2 resources. EC2 are our virtual machines. So you have those resources stood up, but they perhaps haven't been used. So, we can turn those off to again, match the capacity with demand at any point in time. So Comic Relief are a fantastic example of this. Their monthly hosting costs were over $83,000 with their on-premises platform. They're looking at, a run rate of about $6,000 because they've moved to more of a serverless way of operating. So the on-night costs, or their highest cost of the year when Comic Relief have their big night once a year, was $92. So that gives you an indication of the huge savings you can make when you optimize costs. The ability to plan and forecast is important. This particular point is kind of relates more to your organization and establishing a process for being able to budget, being able to forecast, being able to understand what your cloud spend is at any point in time. One of the things we do to do this is we'll do proof of concepts with our customers. So via those proof of concepts, we can actually stand up a full solution, and that will give us a good insight into the operational costs associated with that solution. We have the ability to build business cases. So another thing I'm going to mention later is our total cost of ownership calculator. We have other calculators which allow you to plan in advance regarding spend and estimates on services. The cloud financial operations piece, again, relates very closely to how you would run your business or your organization in cloud. So this usually involves some executive sponsorship for this sort of financial cloud-based initiative, and establishing a partnership between the finance and the technology organizations so that they're working hand in hand to actually understand the spending cloud on a monthly basis and what the mechanisms are to control that spend. And this involves obviously an investment in people to have the relevant skills to be able to execute against that, and the governance and tools, some of which we provide actually in the console itself. So there are some foundational concepts which will allow you to get that governance around your accounts, or around your account structure, around the way you spend. But some of this obviously relates to how you're set up as an organization as well. So to summarize that section, that's about the see, the save, the plan, and the run, and the respective items that I mentioned as I went through those slides. So what can we do to help and assist in this process? We have many cost management services. So this is kind of a snapshot of the services on the right-hand side and their use cases. So there are services that will help you organize and construct cost allocation and governance foundation. There are services which will allow you to report, control, forecast, budget, purchase, make sure that your elasticity in the cloud. Elasticity is a really important concept. So you can see at the right-hand side of that, we have things like auto-scaling groups. That's a fundamental concept in this matching your capacity at any point in time to the demand for services. So we could use auto-scaling groups of a size of 0 instances that scale up based on factors like CPU utilization over a period of time. You don't spend unless you actually need to use the resource. Right sizing, I'm going to talk about in more detail regarding how you might go about one of those exercises, and then obviously the ability to inspect and stay up to date with any resource deployment. I'm going to go through these services as we walk through the presentation, but broadly speaking, these services fit into reporting and alerting type services. So Cost Explorer, the cost and usage reports, budgets, we're actually going to configure a budget. Control type services, so AWS organizations. IAM, our identity and access management fit into that control category. Excuse me. And then governance categories as well, things like Control Tower or our Well Architected process, Trusted Advisor, things that give you governance around your use of AWS. So how does AWS help you to realize value and save cost? So what I'm trying to outline here, I'm going to come back to this slide a little bit later on, are that there are various ways of either proactively or reactively being able to control cost in AWS. So if I walk you through this from the top left-hand corner, there are mechanisms that you can use to reduce costs. So, that's things like being able to change the way you fundamentally procure underlying infrastructure components like virtual machines or EC2. So you might use reserved instances or spot instances or a saving plan. I'm going to talk about what those things are in a subsequent slide. You might use automation. So what I mean by automation is the concept of bringing infrastructure up and down on demand, the fundamental configuration of infrastructure using things like infrastructure as code, which we call CloudFormation, tagging your infrastructure. We have a well-architected review process with our customers, so we review cost on an ongoing basis, and things like the resource optimization recommendation tool. So all of these tools and spending mechanisms allow you to reduce your spend at any point in time on AWS. If I move to the next quadrant, we can also analyze that spend. So we have things like Cost Explorer, the detailed billing report, monthly reports. Amazon also, as another part of the portfolio, has business intelligence tools. So we have a tool called QuickSight, which is kind of broadly equivalent to something like Power BI and those sorts of business intelligence tools. So you can actually use that business intelligence tool to create dashboards and query your spend, visualize that. So that's quite a powerful tool to use to analyze the spend at any point in time. Obviously, that the analyzing spend is a reactive thing. So analyzing spend has been done reactively after the event. Prior to you spending on AWS, you can also estimate cost. So there are tools which you may or may not have used, like the simple monthly calculator, which is kind of gradually being superseded by our new pricing tool, but still available as a simple monthly calculator. Or a total cost of ownership calculator, which allows you to compare the price of your on-premises solution to moving those workloads into cloud. So that's a little bit more proactive. That's kind of the estimation of what you're about to do in the cloud. So all of those three are kind of relatively well understood from a cost reduction, a cost analysis, and a cost estimation perspective. I think this next category is particularly interesting. And I'm just going to give you a flavor at the moment because I'm going to talk about it in more detail and actually configure a budget for you a little bit further on in the session. What this allows you to do is use automation to control budgets at a very, very granular level. So we then use something called Lambda, which is a function in the cloud. The function reacts to the budget and then can do a range of things to control cost within individual accounts or multiple accounts across your AWS organization. So keep these things in mind as we go through the sort of service by service mechanisms. And I'm going to show you what budget and lambdas are and how they interact with each other in a little bit more detail as we move through the presentation. But I think the cost control in particular is a very powerful concept and really plays to the automation you can do in cloud and the interoperation between those respective services to make quite a powerful automation tool to control cost. So the concept with cloud is that you don't have this kind of fixed amount of capacity. So typically with a traditional piece of hardware, you will spend X amount of money and you will have Y amount of capacity. If at any point in time, if we look at the left-hand side of this picture, if at any point in time you are not using that capacity, it's effectively wasted capacity. You've effectively overspent at that point in time, and you're not using the capacity you've procured. If you have a peak business demand, and the most obvious educational example here is something like UCAS, which is kind of really relevant, obviously, for this week. When UCAS are going through their clearing process, their peak business demand is obviously exceptionally high. So what happened to UCAS in 2013 was their infrastructure actually fell over because their peak business demand exceeded the hardware capacity they had at that particular point in time. They've now moved all into AWS. So what we do is we track their demand, and we provide infrastructure based on the demand at any point in time. So UCAS typically, prior to clearing, will do a test run in the weeks before clearing, just to make sure all of their auto scaling is working correctly, and they haven't had any of those infrastructure issues subsequent to moving into AWS cloud. So it's this idea of eliminating waste and meeting the demand at any point in time. Obviously, AWS are quite a large business, which are growing reasonably quickly. We have millions of active customers on any given day, with thousands of public sector customers and thousands of educational customers. So what that allows us to do, it's really an economies of scale type discussion. Because of the economies of scale we're able to do, because we're running multiple customers on the same infrastructure in a secure way, of course, is that we're able to take advantage of that aggregation and actually lower the cost of the infrastructure. In turn, what that does is it lowers the prices, and we pass those price reductions on to our customer, which obviously enhances the customer experience. So since 2006, and this figure is only true as of February the 6th this year, there are probably subsequent price reductions, but we've had 80 price reductions across our portfolio. So this cycle of growth, this cycle of reducing the cost of our infrastructure use because of aggregation continues, and you can expect to see subsequent price reductions as we move forwards as well. CROPS is my way of remembering the 5 pillars of the well-architected review. So a well-architected review is a review which is conducted by AWS solutions architects with our customers on an ongoing basis. So this review, which you can access via your console, so if you go into the AWS console and type well-architected, you will see the well-architected review process with all of the questions, and the questions fall into these 5 pillars: cost optimization, reliability, operational excellence, performance, and security. So you'll notice the first point there is cost optimization. We are targeted as SAs to reduce the cost for our customers and reduce their spend on AWS at any point in time. And I know that sounds slightly strange thing to say, but obviously, that cost optimization and that cost reduction, it helps us, sort of earn trust with our customers. Jeff Bezos's idea with Amazon to make us the most customer-focused business in the world, that one of the ways we do that is by continually seeking to reduce cost. So this well-architected review process is something you can use on a regular basis with whoever your aligned solutions architect is, and cost optimization is a really important part of that process. And as I say, you can access the well-architected tool in the AWS console. If you're thinking of using this process, then go on there, take a look at some of the questions. You can walk through the questions at your leisure. We'll come in and then go through them with you one by one. The result of that process will be a set of recommendations for the 5 pillars I mentioned previously. We can model on-premises costs as well. So we can look at modeling your server costs, your storage costs, your networking costs, the facility costs around space and power and cooling. So we have those models, obviously, as it says underneath. This diagram doesn't necessarily reflect every cost item. Our model generally does, but this diagram is meant to simplify things slightly. So the TCO calculator, and the link is there for the TCO calculator, is the tool we'd use. I think, Amanda, it might be worth mentioning the team that we can bring and use for this particular sort of analysis of on-premises costs. I know you're using that team at the moment in conjunction with one of our customers.
Yeah, absolutely. So that's the cloud economics team that we have here at AWS. So it's if and when you're looking at a slightly larger mass migration type consideration, if you're having discussions internally about whether running 2 data centers is the way forwards, or whether you are looking at potentially decommissioning one of the data centers and using AWS as a secondary data center, we have a fully funded complementary service that the cloud economics team can get involved with, and it's their day job to do this with across public sector and across private sector organizations as well across the globe. And there is an enormous engagement that they will go through with you to help construct business cases, assess what you've currently got, look at how that could work in AWS, not only in a lift and shift capacity, but also in an optimization and re-architecting as well, to really make sure that you're getting the most out of AWS. So if at any point you are beginning to have those considerations internally, which I know many of you on this call today are, that service is available. And as I said, it is complimentary to you with no obligation at the end of it.
Great, thanks, Amanda. The economic benefits, as we say in the previous slide, and that really kind of reflects the left-hand column here. We think there are economic benefits to moving to cloud if we do this right sizing, and if we optimize and continue to optimize over the life cycle. But there are other benefits that go beyond cost saving. So we always talk, if we think about staff productivity, we always think about taking what we refer to as the undifferentiated heavy lifting of things like setting up data centers, racking, stacking, power, air conditioning, etc., everything it means to be a data center. That's our business. That's what Amazon do. So we like to think we take away all of that undifferentiated heavy lifting for you as a customer, so you can focus on the things that are important to you as an organization, the student journey, educating people. When you move to cloud, you will invariably get a benefit from a resilience perspective. If we look at services like S3, for instance, it's engineered to a durability of 13 nines. This is because we have multiple data centers in multiple what we refer to as availability zones across the UK and other global regions. So we can bring that the benefit of us having zones and different what we refer to as failure domains. So from a resilience perspective, that's also a compelling reason to move to cloud. The business agility, one of the things we encourage our customers to do is the experimentation in cloud. So if you have a brand new product, a new service, you can launch that product incredibly quickly. You don't have the long procurement cycles associated with on-premise infrastructure. So you've got the ability to do things much more quickly in a much more agile manner in the cloud. And of course, security. Again, the only thing we do as a business is build data centers in availability zones and regions that our 175 plus services. So we have to be fundamentally secure as a business. Security is known as job zero in AWS. If you think about the things that you'll need to comply with, whether that's SOC 1, SOC 2, SOC 3, PCI DSS, HIPAA, etc., we have you covered from a security perspective. And it's this economy of scale argument again. we're a large business with lots of customers, and we have to have this security nailed down. Okay, so I'm going to talk briefly about cost visibility. So the broad analogy here is that, when you're learning to drive, you obviously need to look at where you're going. And, as you kind of drive faster and you learn to drive better, that visibility becomes increasingly important. So visibility can take many forms in AWS. As you start your journey with AWS and you're maybe doing a couple of small projects, you might be at the left-hand side of this scale. So if it's a simple, relatively static, small environment, maybe the monthly AWS invoice will suffice from an insight perspective. As you move to the right hand of this gauge, complex dynamic environments, large environments in AWS, you will increasingly need more visibility into what's happening and who's doing what in the cloud. So you'll move to using things like the billing console on a more regular basis, the Cost Explorer. You'll be setting up AWS budgets to track and notify spend on a project by project or individual by individual basis. And you'll end up doing things like doing an analysis on the billing, either using our own business intelligence tools or third-party tools. So this is just really a spectrum of tools that you can use from an insight perspective. Okay, as I said, this is probably the longest section of what I'm going to do. Some things I'm going to dwell on, some things I'll move through reasonably quickly. You will get the slides, so you'll be able to refer to something I might have gone through reasonably quickly. If I do go through something too quickly, please stop me and ask me a question at any point. But before I move into this section, do we have any questions on anything I've shown so far?
Yes, Andre, I've just Phil, we just had one in the chat just quickly. Will the slides be available after the presentation? And the answer is obviously yes. But also, Andre, just so you know, I'm recording this session. So I'm to any late joiners, I said, please make this session as interactive as possible. We won't be sharing any confidential information from any of your accounts. If you've got questions that you're happy to share with all of the users, then please feel free to ask. And if there's anything that you want to stay behind and ask Phil at the end after the recording, if it's specific to your account or spend, then please feel free to do that. So I will be sharing the recording as there are other colleagues at other organisations that I know couldn't attend today that do want access to this session.
Great, thanks, Amanda. Okay, so firstly, one of the things it's useful to do is to understand where the low-hanging fruit is in your organisation. So some things you're going to do from an optimization perspective might be quite complex. So if you look at the top right-hand corner here, if you move away from a more traditional virtual machine-based architecture to a serverless architecture, for instance, it is much more cost-effective way of consuming cloud resources. So you might, for instance, move away from using compute on EC2 instances to using Lambdas, where you're just essentially hosting a function. But that can sometimes involve, refactoring applications and doing a fundamental redesign. But it will have a big impact from cost. But there are other things. There's low-hanging fruit. So the items in green there, particularly at the top of the green column, these are things which don't have a great deal of complexity, but which might have a huge impact on your organization from a cost savings perspective. I'm going to talk about savings plan and what savings plan is in a couple of slides' time, but things like savings plan or right-sizing your environment prior to migrating into AWS are relatively simple things to do, but can have a huge impact on the cost and how you've optimized costs in AWS. So kind of always keep this in mind. Where's the low-hanging fruit? What can we do quite quickly to optimize what we're doing in AWS? And we can think about some of those more kind of complex things and work in conjunction with you to realize those more complex things, maybe on a mid to longer term basis. So right-sizing your resources is really important. If you think about our virtual machine portfolio, hundreds of different virtual machines in different families, different characteristics. We'd encourage our customers to do a little bit of experimentation perhaps around this. So it depends on the customers. Some customers might start low and move up, up the instance range to sort of get their optimum balance between cost and user experience or application experience. Other customers work from sort of on a top-down basis. Because of the ease of launching resources in AWS, you can take that experimental approach to right-sizing your environment, whether that's CPU, RAM, storage, whatever your network needs are. It's a good idea to do this before you migrate. We can obviously optimize once you're operational in AWS Cloud. That does involve, depending on what you're doing, some mechanisms around maybe swapping up certain families of instance for other families of instance. We'll come on to that again in a few slides' time. So how do you pick your instance family? There's a link there with a guide to all of the instance types. They range from what we refer to as general purpose instances. So some of you might have used T2s and T3s, and you might have used T2s and T3s as part of the free tier to just do some experimentation on. Incredibly low cost way of standing up virtual machines in the infrastructure. Might not be right for production workloads, where you might move to an M5 or an M5A family of instances. If your workload is more kind of compute intensive, you might be using the C family. C stands for compute there. The memory optimized family, so you might be using the R, so R stands for RAM there. There are different categories of instance depending on what your workload is demanding at any point in time. So the last two there are accelerated computing, so that's computing with GPUs, and storage optimized instances. So this is typically where you need a lot of IOPS or throughput from a storage perspective. How do you right-size after you've deployed? You can use our tools to investigate where you might have some underutilized resources in AWS, agree on a resizing process and what you need to resize there to, obviously understanding any other business logic or constraints as part of that exercise. And then you size to what you need and continue to use those insights into your workload that I mentioned earlier to monitor the performance of the workload, and then obviously all being successful, celebrate the savings when you have. So this is one of the tools that we that we use within AWS. It's the resource optimization recommendation tool. You can just run it in your account, and it will tell you things like you happen to be using a very large instance, not particularly effectively in this case. Your CPU utilization, if you see in the picture there, is 6%. Our recommendation would be you move to another instance in that family or another instance family type. So that's a tool that we can use to help our customers if they're not using the resources in cloud optimally. Trusted Advisor is another tool I mentioned earlier. So if you have old snapshots of block storage volumes, for instance, and those snapshots are so old that they would no longer have any use, Trusted Advisor will tell you how old those snapshots are. You can then choose to put those in a vault for longer term storage or delete those snapshots. If you're using elastic IP addresses rather than Amazon's range of public IP addresses, you are charged when you use those elastic IP addresses. You're not charged for our public IP version 4 addresses. But if they're unattached and they're not being used for any reason at any point in time, Trusted Advisor will tell you that. So you could hand them back into the elastic IP pool and save yourself some cost. Trusted Advisor will tell you where you've got idle virtual machines or EC2 instances. It will tell you where you've got idle relational database instances. Where you have EBS is our block storage solution. So where you've got block storage volumes that are not attached to any virtual machine. If they're not attached, what are they being used for? Do you still need them? And whether you've, you get this as our customers are increasingly, using more AWS services and doing more experimentation in the cloud, they might have configured load balancers that have subsequently become idle because that service is no longer being used or the load balancer is unattached. Trusted Advisor will tell you whether you've got idle or unattached load balancers. So it's another mechanism via which you can optimize your costs. In addition to AWS, we have third-party tools. So Cost Explorer is one of our fundamental services to take a view into your costs. I'm going to show you Cost Explorer later. TSO Logic, company that we now own. We use TSO Logic to do a pre-migration assessment and to assess how you might move to on-premises onto AWS. So TSO Logic has a tool to kind of optimize that mapping between what you're doing on-premise and how you might map them into AWS. So it also factors in optimization as part of that migration process. And then there are many third-party tools. I'm not sure if people are aware on the call of something called the AWS Marketplace. So the AWS Marketplace is where our third-party ISV partners publish their solutions. So you'll see, Stacks, Cloud Health, Density, and others publishing their tools via that marketplace. There are, many, many thousands of tools, not just related to cost optimization. Red Hat would be on there, Cisco, Juniper, all the vendors you're probably more familiar with from an on-premises perspective also operate in AWS Cloud. Think about having a policy rather than things being on, the default position for a virtual machine is that it's off, rather than the default position being on. And you can save 70% in those sorts of non-production environments that this sort of thing lends itself to. That's not just on virtual machines. You can also turn off RDS instances, and you can see the difference in the graph below. That correlates to thousands of hours worth of VCT usage just by having this default always off position in non-production environments. You can save an awful lot from a dev and test perspective. Auto scaling is fundamentally important, and the use of auto scaling groups to cost saving. So this concept that you match the demand at any point in time with the infrastructure that's being provisioned. You can write really granular policies around auto scaling to reflect a number of different metrics to expand out and contract back in again, depending on the fluctuation. There are tools that we can use from an elasticity perspective. Auto scaling I've just mentioned. There is a tool called the EC2 Instance Scheduler. What the EC2 Instance Scheduler does is schedules tools up and down on a kind of time-based basis. So what you will do is define, let's say, a working day between 9 o'clock in the morning and 5 o'clock in the evening. You might turn all your infrastructure on at 8:30 and turn it off at 5:30. So Instance Scheduler allows you to do, use cases as basic as that, and also much more sophisticated use cases. There are tools from third parties as well for doing this sort of thing. Okay, I know for some people on the call, you will probably intimately understand what I'm just about to say, but I'm going to say it for the benefit of the people who perhaps don't. So fundamentally, there are three ways in which you purchase virtual machines on AWS. On demand is pretty simple to explain. You provision a machine on an on-demand basis, you turn it on. For the lifetime of that machine, it's yours. It's not contended in any way. It's billed for on a per second basis, and then you turn it off and it stops charging you for that virtual machine, for that EC2 instance. That's far and away the most flexible way of using infrastructure on AWS, but that flexibility does lend itself to increased cost. There is a premium you would pay for using that flexibility. That suits people sometimes, but not always. So the other models that are more cost effective are reserved instances. So reserved instances are where you make a commitment. That commitment's usually on a 1 year or a 3 year basis. There are more flexible models that we can actually provide to you via some of our partners, which are more kind of financial partners than technical partners. But typically that's a 1 year or a 3 year commitment. So you'll understand that you have a baseline of demand for infrastructure over either a 1 year or a 3 year basis, and you will tell us in advance that you're going to use X amount of infrastructure. You've then got a choice. You've committed yourself to using that infrastructure. You can pay for it all up front. You can pay none of it up front and pay for it on a kind of operational basis across the term, or you can pay some of it up front and then the rest of it as an OPEX charge across that 1 year or 3 year period. There's an up to 72% advantage to using this category of instances. So what we see, and this is just my experience of working in education, for customers that are doing high performance compute, just as an example, they might have a baseline of reserved instances which reflect a baseline of demand from a high performance compute perspective. And then they will top that baseline of reserved instances up with either on demand or spot on a kind of case by case basis. So that brings me to spot. So spot is spare capacity in AWS's infrastructure at any point in time. Spot has a market price. That market price can be up to 90% less than the on-demand price. So if we look at on-demand, reserved instances up to 72% less, spot can be up to 90% less. So you decide what you're going to pay for a spot instance. The decision is that you'll pay somewhere between the market price for that EC2 instance at any point in time and the on-demand price. And where you position that price is entirely dependent on your attitude to risk. So you could bid very close to the market price, in which case you're going to get very close to that 90% off. You could actually submit a price which is the same as the on-demand price. There'd be no reason to do that. You might as well buy on demand, but I'm just sort of exaggerating to make a point, really. You can use things like Spot Explorer to understand how the spot prices fluctuated over a period of time for a family or an individual type of instance within a family of instances. So you will be able to understand how the prices fluctuated, and that will inform the way you submit a price for a spot resource. This is kind of a fundamental concept from an infrastructure perspective. So I'm just going to stop there just to see, Amanda, if there are any questions in the chime window or anything people wanted to ask live.
Yes, so there was one question with regards to purchasing options. So savings plans and reserved instances options for AppStream. Do they apply to AppStream?
So savings plans come in two flavors. There are what's referred to as compute saving plans, and then there are EC2 savings plans. EC2 savings plans. So let's be clear what saving plans are before I go any further. So savings plans are really version 2.0 of reserved instances. You can still buy reserved instances. Lots of our customers are used to that kind of reserved instances model. Saving plans are more flexible. So it's kind of a more flexible way of purchasing reserved instances. The EC2 type of saving plan is self-explanatory. It only applies to EC2. The compute saving plans doesn't just apply to EC2, it applies to EC2, it applies to our container offerings. So if you wanted to use Kubernetes or Amazon's own container solution, it applies to Lambda as well. I'm not sure, Amanda, you might know the answer to this question, whether it applies to AppStream. I think it doesn't, but I'm not 100% certain of the answer to that question. So I'm going to take that away as a question.
No, that's okay. I will. I think we can double check it just to make sure, but I'm almost 100% certain it doesn't, because for AppStream 2.0 there is already educational pricing available for university customers on AppStream that's charged on a per hour per user basis. So it would be unlikely that the RI or savings plans would be applicable.
Yeah, absolutely. And what we've launched relatively recently for AppStream is an AppStream calculator, which you can download. It comes as an OpenCalc or Microsoft Excel spreadsheet, and the educational licensing is in that model. And then what you can do on a day-by-day, hour-by-hour basis is tell us how many desktops, or sorry, how many applications you want to be streaming at that point in time. So it's a really granular model. Maybe we can take an action, Amanda, to make sure everybody on the call gets that link prior to us dropping the call today.
Sure.
Yeah, great. Okay. Any other questions, or shall I proceed?
No, we're good for now.
So reserved instances are, a well understood concept, been used for many years, allows you to achieve those savings. So for a standard reserved instances, that can be up to 72% for what we call a convertible reserved instances. So with convertible reserved instances, you can, during the lifetime of the reserved instances, whether that's contract is 1 year or 3 year, if you decide that you don't need that particular type of instance anymore, you can convert them into other instances. Because you get that flexibility, the discount is not quite as much on convertible reserved instances, but it does give you a little bit more flexibility to almost trade your reserved instances. Reserved instances do require a bit of planning, though. You need to understand what instance family you're going to use, the size of that, the operating system, which region and which availability zone you're going to run them in, whether that's a shared or dedicated tenancy. So those sorts of things with reserved instances have to be defined up front. Now, that's not the case with savings plans, and that's why we refer to savings plans as almost version 2.0 of reserved instances. So in this case, this is an EC2 savings plan. So the only thing you have to define up front here is the family of instances and the region that those families are going to run in. That becomes even more flexible if you take out a compute savings plan. So if you remember, compute savings plans extend beyond instances. They extend into our container offerings and Lambda as well. So all three of our major compute offerings in AWS Cloud. So compute savings are much more flexible. You don't achieve the same amount of discount for obvious reasons, but it's up to 60%, 66% discount, but you don't need to plan anything in advance. You can use this very flexibly. RIs can still work with savings plans. I'm just going to make that statement. You can still continue if you're already using RIs and you're still purchasing on that basis. You can continue to use RIs in conjunction with savings plans.
Phil, if I could just interject here as well to let everyone on the call know, there's no lower limit to RIs or savings plans either. So I'm aware that the organisations on the call are all in different kind of stages of their cloud journey. And I have customers that have reserved instances and savings plans for $1,000. And then I have others that go into the tens and the hundreds of thousands of dollars. So don't think for a minute that you are either too small or too large to use these. Obviously, the savings are relative. However, there is no lower or upper limit for these.
Thanks, Amanda. So I'm not going to go through this decision matrix in detail because, as we said, you will get the slides. But the sorts of questions you're going to ask when you think about is this going to be a compute saving plan? Is this going to be an instance, EC2 instance-based saving plan? Should I use a convertible RI or should I use a standard RI? This is almost a decision matrix that will allow you to, sort of ask yourself those questions, and this will probably be able to answer your question regarding, whether you which of these mechanisms you should be using to save costs. There's a second part of this table as well. I'd really invite you to, when we send you the slides, maybe look at this, and if you've got any subsequent kind of follow-on questions, please get back in touch with us. We can talk you through the decisions and what will be more appropriate for a particular use case or your individual organization. How do you get started with savings plans? So if you go into Cost Explorer on the console, that will guide you through the entire purchasing process. So you get the ability to review your saving plans recommendations, customize those recommendations based on your needs, based on the decision matrix in the previous slides. Review your hourly commitments, add those to the cart, and understand whether that's going to bring in any other eligible usage from EC2 or Fargate. I'll mention what Fargate is in a couple of slides, in a few slides' time. Reserved instances can still be used for non-compute services as well. So the Amazon services which offer RIs are obviously EC2, but it also applies to services which obviously from a foundational perspective have virtual machines as part of their solution. So RDS are our relational databases, MySQL, MS SQL, Postgres, etc. Redshift is our data warehousing solution. Elasticache is a Redis-based or Memcached-based caching solution that you typically use as a caching layer in conjunction with RDS. Elasticsearch is our document search solution that allows you to stand up elk stacks in the cloud. DynamoDB is a NoSQL key value database, and Amazon CloudFront is our content distribution network. So even though these are kind of services and sort of higher layer services, the foundational components for these services are still, virtual machines. So we're able to offer RIs in conjunction with these services as well. Think about where you can use Spot. Some of my customers are particularly successful in using Spot for high performance compute, but it also lends itself quite well to things like big data. So, if you're standing up a Hadoop cluster in the cloud using our Elastic MapReduce service, that might be another good use case for Spot for Spot instances. if you have the ability to have a kind of underlying mechanism to provide resilience, so if you think about Hadoop and the resilience model associated with Hadoop, or the ability, for instance, with high performance compute jobs to checkpoint those jobs, Spot might be an appropriate mechanism to use. Maybe for containerized workloads as well. So if you're using, Kubernetes, our Kubernetes service, the Kubernetes service and the kind of orchestration around that will ensure that you have the right amount of containers for any particular service up at any point in time. So Spot might lend itself to these sorts of workloads. A large saving to be had on Spot. There's no difference with Spot. From an infrastructure perspective, it's exactly the same as on-demand and reserved instances. Sometimes I think our customers think it's fundamentally different infrastructure. It isn't. It's just unused capacity at any point in time on the cloud, and we allow our customers to take advantage of that. The pricing model has changed for Spot. It used to involve what we referred to as a bidding process. That changed some time ago. You just set your price and largely forget it. The third part of this diagram is interesting. So one of the ways we mitigate the effect of Spot instances going down is we use something called a Spot fleet. What Spot Fleet allows you to do is specify a fleet of Spot instances for a specific purpose or for a specific workload across different families of instances. So obviously the risk profile and the market fluctuations based on supply and demand for any family of instances will be different than another family of instances. So you basically spread your risk of the entire fleet going down by specifying a Spot fleet across different instance families. So it's a way in which we can increase the uptime of a Spot instances and kind of mitigate that. They occasionally get turned off if the market price gets too high. If you're using storage in the cloud, if you're using our block store, then manage the storage class. I'll explain a little bit more in the next slide what that means. There are different storage classes for EBS. Similarly, for our file system in the cloud, what's not shown on this cloud is we also have a Windows file system called FSX for Windows and a Lustre file system in the cloud. With EFS, you now have an infrequent access class, which costs less. So again, think about your use case. Does the data need to be immediately available? If it's accessed on a more infrequent basis, the EFS infrequent access class might be more appropriate. With S3, if you're using object storage, there are different categories of S3 storage. There are the S3 categories themselves, and then there are archive classes of storage, which if you're using something like Glacier Deep Archive, can get up to up to as low down as $1 per terabyte per month. The idea behind that pricing is it's competitive with tape. So, think about the requirements of that data. If it's something that needs to be archived on a long-term basis, something like Glacier Deep Archive might be more appropriate. So for block storage, as I said, I was just going to elaborate on that in a little bit more detail. Think about the profile of your workload. Does it actually need to have lots and lots of provisioned IOPS? If it does, use our IO1 class of service. The default, though, is what we refer to as GP2, which is general purpose SS. So when you're specifying an EBS volume, if you don't do anything, the default behavior will be that it will provide an SSD class of storage. You might not need that. You might need the two categories underneath are hard disk-based storage. So our throughput optimized hard disk, what we refer to as SD1, 50% more cost effective. Our cold hard disk storage, our SC1 category, is 75% more cost effective than GP2. So again, think about the workload, think about what it needs to run on at any point in time to make it more cost effective. This is really kind of reiterating a point I made a couple of slides ago. just think about the policy around your data. Is this active data that needs to be accessed on a regular basis? Is this infrequently accessed data, which would be in more of a warm category, or does it need to be archived? And S3 has all of those categories or tiers of storage depending on the classification of that data. If you don't... Oh, sorry. Did I get a question there?
No, I think it sounded like children joining the call, as we've all been there. Oh, don't be silly, Chris. Don't apologise. My kids have featured on many of mine before. Don't worry.
Absolutely. On camera as well. So if you don't know which S3 tier of storage you need for any given workload, turn on S3's intelligent tiering capability. So that will look at the changing access patterns around the data and put the data on an appropriate tier. So it might, for instance, take it down from our standard S3 service to something called standard infrequent access, as you can see on the left-hand side. Or if the durability requirements around the data are not large, it might bring it down to a single zone infrequent access tier of S3. But S3, turning on S3 intelligent tiering is a good way of saving costs without having to actually think about how you're saving costs. These slides are by no means comprehensive, and I know it seems like perhaps a little bit of a long drawn-out slide set, but there are many, many, many more things I could talk about in terms of saving cost. So I'm just going to touch on a couple of these. If you're hosting a static website, don't do it on EC2 instances. It's not a particularly cost-effective way of hosting a static website. Do it on Amazon's S3. In addition to it being cost-effective, you get all of the durability benefits of S3, that 13.9's resilience I mentioned earlier. If you're delivering content to your end users, think about using a content distribution network. That will push content closer to your customers, so it can lower the compute at your origin or your origin server, and it can lower the amount of data transfer you're doing. Use cloud formations. So this is essentially infrastructure as code. So if you're doing the same thing over and over again, standing up the same infrastructure stack, don't configure it by hand. Just write some JSON or write some YAML, which tells the cloud how to stand up that infrastructure stack. So that obviously saves time from a developer perspective. We make extensive use of cloud formations. Think about running your resources in a cheaper region. So I do a lot of work with the University of Manchester. I recently did a lot of work on their HT Condor cluster. We now burst their Condor cluster into the cloud, and we run anything up to 2,500 and 3,000 Spot instances at a time. What they've done is written some Python code which actually polls our pricing APIs. What it gets back from polling the pricing APIs is the cheapest region to run that job in at any point in time. So depending on the security requirements and the data sovereignty requirements around that data, they are invariably running their HT Condor jobs in North Virginia because it's the most cost-effective way to run Spot instances at that point in time. That obviously changes as well.
Phil,
yes,
we've had a question come in which is relevant at this point to interject with. If you are looking at utilising Spot, is that only within your selected region, or could it pull from any region? Thinking about kind of from a GDPR compliance perspective.
Yeah, so I think I might have answered that question with what I just said about the way Manchester operates. So they, for jobs that don't have data sovereignty requirements, the jobs that don't need to. So we have this concept of regions. Regions you can think of as compliance zones. We would never move data outside of a region unless you specifically asked us to, or unless one of our customers did it themselves. So, one of the reasons you might move data outside of a region is to do disaster recovery, for instance. But what Manchester do, if they don't have particularly stringent security requirements around a particular high throughput compute or HD Condor job, they run it in North Virginia on spot. So they're spinning, 2,500, 3,000 VMs at a time. There's a great case study. We can perhaps give you the link for that particular case study. What they were able to do was reduce the processing time for a particular category of jobs, which the case study is based around, from 130 days to 6 days, because they were using Spot, because they were using the lowest cost region. They were able to do it in a really cost-effective way. It's a really good case study. Amanda, can you make a note to maybe distribute that as a case study?
Sure.
Great, thank you. So serverless, I mentioned previously, moving away from using virtual machines to using things like Lambdas, API gateways, NoSQL databases, host your static front end in S3. All of those are the typical components that would make up a web application that's been architected on serverless principles. Can be very, very cost effective, but does involve some, if you're trying to re-architect something that exists, there can be a little bit of complexity. If you're developing something new, not as much complexity. Containerize your workloads. You can move your commercial database. If you're using, for instance, an Oracle database, you could migrate that to a Postgres database, for instance, using our relational data database service, and using autoscaling, as I've mentioned probably 2 or 3 times now, to match supply and demand. Tags are important as well. So it's important that you turn on cost allocation tags. Those tags can then be used to really look at, that visibility piece that we mentioned earlier, and the ability to kind of control costs on a very granular level. So we have tools within our own ecosystem of services like the AWS Tag Editor. There are other open source tools available on the marketplace. As there are for commercial visibility as well. So you can use AWS QuickSight. QuickSight is our business intelligence tool, which allows you to look at the billing data and visualize that data in many, many different ways. Or Cost Explorer, which you can use the Cost Explorer API to use in conjunction with third-party tools, for instance. So there are other tools mentioned below. There are tools like Tableau and Power BI, but we do have our own tool, AWS QuickSight, built into our ecosystem of data visualization tools. So one customer using the automation principles that we mentioned previously, were able to produce results within a single week. So they were able to reduce, in this case, 320 idle instances down to 50 idle instances within 1 week, just by using the principles of the automated process for turning off resources using Lambda scripts. Now, I'm not going to, at this stage, I'm not going to talk about this in great detail because I actually walk through this at a later slide. And there are tools to control EC2 Spot as well. So there are tools within our ecosystem, and there are third-party tools. Likewise with reserved instances, so Cost Explorer, budgets, and then the various third-party tools as well. EC2 and EBS are charged for on a per second basis, so you get good granularity from a billing perspective. I mentioned this previously, that you're able to convert RIs as well. So we have the ability to exchange reserved instances even after they're operational, and modify those instances, split maybe a larger instance into a number of much smaller instances, which is what you can see on the left-hand side of this process, and then do that exchange mechanism back another point of the process where we're exchanging large numbers of very small instances for larger instances. So this process can work. What we're trying to illustrate here is that this process can work in both directions. You can use code as control as well. So I would strongly encourage people to use the identity and access management console to write policies to implement role-based access control. So the policy you see below you, which is just a simple policy expressed in JSON, we have tools to enable you to construct this JSON using GUI-based tools. And this is restricting this. If this policy you see in front of you were applied to a particular user, it would restrict that user to using T3, A1, and M5 families of instances. So you can begin to use our identity and access management or the code associated with that to apply policies to control cost for individual users or even for groups of users. And we'll talk about how those groups of users work in a few slides' time. You can provide self-service. So the way this works is that we use that concept of infrastructure as code or CloudFormation to build infrastructure, and we surface that via a service catalog, which has controls around which users can and can't launch particular types of resource. So again, at the front end of the service catalog, you're controlling the costs by giving an individual user a list of products that they're able to launch. So just to use probably a highly exaggerated example, if you had a user that was involved in HPC research, you might not want to present them with the skill to build an Alexa skill, for instance. That might not be something that you would want them to spend on in cloud. I'm really exaggerating to make a point there. That service catalog can be integrated with your existing IT service management software tools, stuff like ServiceNow and BMC, standard tools from that area. You can govern down to the individual lines of code. So you can use things like Amazon's Code Guru to profile your code, identify areas of code that happen to be associated with high amounts of spend. So you can use Code Guru to control cost down to the code level. Tagging, I've already mentioned. And the ability to identify cost variances on a proactive basis. I'm just going through some of the things I've already mentioned as I've been through the slides. The solution you see here is the solution for the EC2 instance scheduler. So you specify a schedule in Amazon CloudWatch. That schedule is then used to trigger a Lambda. The Lambda works in conjunction with a NoSQL database to understand the state at any point in time, so to understand the instances you actually have provisioned, and then looks at the desired state and the state and brings instances, whether they be EC2 instances or RDS instances, up and down based on a schedule. So as I say, you can have some very simple 8-hour-a-day, 5-day working week type scenarios with this. So you can go into a lot more detail. It can be a lot more granular. It goes back to that principle of not having infrastructure turned on unless you're using it at any point in time. I'm going to talk through this in more detail in a subsequent slide. So we have the AWS Compute Optimizer, which is a no-cost service. It uses machine learning to make right-sizing recommendations. You can use, rather than using Intel-based instances, you can use their AMD equivalents. Those families of instances usually have the small letter A after them, so you can see M5As and C5As there. In most cases, they're a drop-in replacement, but they're more cost-effective, up to a 10% cost saving over comparable EC2 instances. We now have both Generation 1 and Generation 2 Graviton instances. So these are ARM-based instances. If your workload will run on ARM and doesn't necessarily require x86 from a processor architecture perspective, make use of the Graviton instances. They're a very cost-effective way of doing things. Spot instances I've already covered. Use the latest generation as well. So if you look at the R family, for instance, R5 is the later generation than R4. What that usually equates to is better performance, and the cost will either be the same or lower. If you are using an instance for the first time, I would encourage you to use an R5 or a C5 rather than an R4 and an M4. So you always use the latest generation of instances where you can. So Fargate is something we use for our container solutions. Typically, when you're using containers, you have an underlying cluster of EC2 instances that you would manage. What Fargate does is takes that management of that cluster away from you and just scales the cluster up and down automatically. So that, sorry, this slide's a bit old. It is available for EKS now. I seem to have dropped an older slide in there for some reason, but it can be used with our Kubernetes solution or Amazon's native ECS container service. So it has that concept of scaling the cluster up and scaling the cluster down automatically. So if you use Fargate, you don't need to manage the cluster, and you take advantage of that auto scaling by default. This is probably a little bit advanced for most of our customers at this point in time, but obviously tune your lambdas so that the amount of memory and the execution time will affect the cost of the Lambda. The one thing I would say with Lambda is the first 1 million executions of a Lambda or a function in the cloud are free of charge. So in quite a lot of cases, it's a no cost or low cost option from a compute perspective. API gateway is usually used to present a REST API gateway. That might be the front end for a Lambda, for instance, which is going to do some of the back end business logic. We've recently released HTTPI-based APIs. They're kind of like REST APIs, but with not the same amount of functionality, but they cost far less. So think about whether you need to use an API gateway or a HTTP API gateway. You can save a lot less using HTTP. RIs I've already covered. So Aurora is a category of serverless relational databases. It comes in two flavors. You can use it as Postgres or MySQL. It doesn't use any instances that you control. So when you use our RDS service, you usually specify the family of instance to use. This actually scales up and down seamlessly. So this is our kind of more cloud native version of a relational database that gives you that kind of bursting up and down, the ability to meet bursty or variable or unpredictable workloads. Our Aurora service also produces something called read replicas. So if your database is very read heavy, what we tend to do is redirect the reads to a read replica, and then we can auto scale those read replicas again up and down based on demand. So you take advantage of this using the capacity that you require at any point in time, and the cloud automatically provisioning that capacity for you. RDS proxy is something that sits between your database client and your database. That allows you to reduce the load on your database. It takes away some of the, it's almost like a compute offload service, as well as doing some other things from a connection pooling perspective. So you might want to think about putting RDS proxy in front of your databases. For our data warehouse, we can do a pause and resume. So those clusters associated with your data warehouse don't need to be permanently switched on anymore. They can be paused and resumed as you need them. You can elastically resize your data warehouse as well. Okay, so I know that was a bit of a whistle-stop tour, and as I say, even that was doesn't talk to all of our 175 services plus and how you might optimize them from a cost perspective. But hopefully it gives you a flavor of some of the things you can do with some of the foundational services, particularly around compute and storage, content distribution, those sorts of things. So just before I go into the summary and the console, I'm just going to stop there, Amanda, to see if there's any questions in the chime or anything anybody wants to ask on the meeting.
Nothing in the chime, but I'll leave it open to the audience to ask questions.
Okay, I'm just going to move forwards. So back to the diagram I showed you at the beginning. So there are, hopefully what we've demonstrated there are various techniques we can use to reduce cost in the cloud. Some of those things are procurement options. Some of those things are automation in the cloud, whether that be CloudFormation or auto-scaling groups. We can use tagging to get better visibility. We have a well-architected review process that we as solutions architects are engaged in, and we can use tools like the resource optimization recommendation tool and Trusted Advisor and those sorts of tools to reduce cost. There are various mechanisms via which we can analyze spend, Cost Explorer, the detailed billing reports, or we can use our business intelligence tools. We can estimate cost up front. It might be worth showing actually the simple monthly calculator. I'm just going to come out of presentation mode for a second. I needed to reshare, so you should be able to see the simple monthly calculator now.
Yes.
Yeah. So this has been superseded by the AWS pricing tool, and gradually we're using the newer pricing tool rather than this tool. But I think this is a really good tool to show you from a demonstration perspective of how you might go about estimating the usage for something as simple as a couple of virtual machines. So you can see the services on down the left-hand side here. I've got EC2 selected. I can then change the region so that I am in the London region. Let me just increase the size here so you can see things a little bit more easily. I'm in the London region, so I can begin adding test virtual machines. I'm going to say I need 2 of these machines. I'm not going to add the utilization because of something I'm going to do in a second. We could use let's say a C5X large instance. So this is just the C category or the compute intensive family of instances. And this X large tells me how many virtual CPUs and how much memory this particular machine has. And then I can look at my billing option. So on demand's the most costly way of doing it. Let's go for the most cost effective, which would be a 3-year all upfront reserved instance. I can then begin to add an EBS volume. So this is adding a storage volume. I'm going to use general purpose SSD. Oh no, let's be more cost effective. I'm going to use the cold hard disk category. My snapshots are, let's say on a monthly basis, 10%. So what's happening here is it's producing on this other tab. So I'm specifying the services here. Let me go and specify my support level as well. So I'm going to specify business support rather than enterprise. Enterprise comes with a technical account manager, which adds a lot of cost. I would not use that if I were you at this point in time without a long discussion with us. So this now produces a tab of my monthly bill. So if I expand this tab, I can begin to see how much I'm going to pay on EC2 services, what my support costs are, the support for the reserved instances, what my EBS snapshots are going to cost, what the EBS volumes are going to cost. I can export that as a CSV, or I can Or I can copy that link and share it with anybody. So if I were to drop that onto the chat session for the meeting we're on at the moment, you can all click that link now, and it will give you, it will show you the very basic estimate I've just pulled together on screen. So that's just an indication of how you might use the cost estimation tools. You can do similar things with the pricing tool or the TCO calculator. I'm going to stay in non-presentation mode because I will flick between the console at this stage. Okay, so I'm going to talk a little bit more about this this area in red here, which I alluded to earlier on, and how you use things like budgets in conjunction with Lambdas and AWS organizations. So let me just go ahead and go into the console and construct a budget. So I'm going to go into the cost management part of the console, and you can see what I have in front of me. This is just something I was looking at earlier today, are some recommendations. So this is making a recommendation that I don't use this category of instance, and I could make over $1,000 monthly saving if I were to use a different size of instance. So there's just a little insight into what the recommendations might look like, because it's got a whole set of recommendations. I've probably not specified optimal instances because I'm doing a lot of experimentation in my account. Let's just move into budgets. So I'm just going to very quickly, because it can feel like this is very complicated, and it's not actually that complicated to create something which I think is quite a sophisticated mechanism to control your spend in cloud. So I'm going to create a budget. The budget in this case is going to be a cost-based budget rather than usage, reservation, or a savings plan budget. I'm going to call this test. Test August. The budget's going to be on a monthly basis. I want it to start this month, and I'm going to make it a recurring budget rather than a budget that has an expiry date. Just for the ease of showing you, I'm going to use a fixed budget, and let's say the budget in this case is going to be $100. which is a lot less than my last month's spend, as you can see. As I say, I'm doing a lot of experimentation in my account. So what are the parameters associated with this budget? I'm just going to get it to track upstream usage in this case. And maybe workspaces as well. So workspaces and AppStream are our two offerings in the end user compute area. So AppStream streams apps, workspaces are complete desktops in the cloud. What do I want this budget to apply to? I'm going to apply it to my linked accounts as well. So I happen to have an AWS organization with some test accounts. I'll show you what an organization is in a couple of slides' time. So I'm going to apply the filters to make it apply to those accounts. Let's just make it for the London region. And as you can see, I can then begin to build up a very complex picture for this budget of different instance types, different usage types. I can include budget tags here to tag for specific projects, etc., etc. I'm going to leave it as is. It's AppStream and workspaces for all my linked accounts in London. I'm then going to configure an alert. I want the alerts to be based on actual costs rather than forecasted costs. I'm going to say to alert me when we hit 75% of that budgeted amount I specified earlier. Contact me. I'm then going to add our simple notification service. So I'm going to explain what simple notification service is with a slide in a second's time. So if I go into SNS, and I'm going to pick a topic, and this topic is going to be called Fill Bill Alert. That's an Amazon resource name. So that just uniquely identifies this resource in Amazon. So I'm going to say this is the topic. The budget in this case is it's a publisher subscriber model. So what the budget is doing is publishing to that SNS topic, and then we have a whole bunch of subscribers if that publisher publishes anything to that topic. So now I can confirm the budget and create. So that's an end-to-end budget creation process for quite a specific budget for a specific set of accounts in a particular region for 2 individual Amazon services. So what have I done? I've used something called an SNS, a simple notification service topic. So I pre-created a topic. My budget is the publisher. So when my budget hits that 75% threshold of the amount, it will alert the topic. And then I have some subscribers to this topic. To make this solution work that I'm going to show you, we would actually use a Lambda as a subscriber to this topic. So what's a Lambda? A Lambda uses an event source. In this case, the event source is the SNS topic. That produces an event. It runs a function in the cloud, and that function interacts with some AWS service. So pretty much the entire portfolio has an API. If it has an API, Lambda can talk to it and do something with that service. The service it's going to interoperate with in this case is called the Identity and Access Management Service. So that service is responsible for understanding principles and how you authenticate those principles, the request and how that request maps to authorization. So what this is understanding the principles in most cases are users. So it's doing authentication and authorization for those users against, things like console operations or resources like standing up an EC2 instance. To pull all of that together, what's happening here is the budget is reaching a threshold, producing a notification. It's a publisher to this SNS topic. The SNS topic is subscribed to by the Lambda, and the Lambda is then interacting with the IAM service. So what's the result of that end-to-end operation? The result is if somebody's overspent on a particular service, you could actually revoke their access via IAM to that service. You could send them a notification to say, you've overspent on high-performance compute. Our automated process has revoked your access to that particular service. You need to come and have a chat with us about your budget, the budget associated with your particular research project. And in that way, you are controlling access to AWS services. Now, that's quite a draconian use case. It can actually be more severe than that if you want it to be. You could get the Lambda to talk to the actual service. So you could get the Lambda to talk to where it says, I am here. This could be the EC2 service to actually bring down the resources that they've overspent on. Now, it can be as benign as, sending somebody a text to say, did you realize you've just hit 70% of your threshold for this particular project? Maybe we need to have a chat about your project and understand, what the spending patterns are going to be moving forwards. Or it can be the kind of what I refer to as relatively draconian use cases, like revoke somebody's access to the service or bring those resources down. It can be as simple as a showback mechanism, or as extreme as the 2 cases I've just mentioned. That can be quite a complex thing to understand. So I'm just going to stop. I'm going to pause at this stage to see if anybody has any questions around how that works. And hopefully what that illustrates is really the power of automated mechanisms in cloud and the power of being able to interoperate between various services and other services using other services via their APIs or using SNS as a notification service. So what we get the ability to do is glue all of these services together as an end-to-end automated cost control mechanism. But yeah, I said I was going to ask for questions. So does anybody have any questions on that?
Nothing on the chime.
Okay. Okay, so that's really the end of the explanation of how all of those services fit together. I'm just going to talk a little bit about AWS organizations. Organizations are a mechanism via which you organize your AWS accounts so they fit together in the kind of structure you see in front of you. So those organizational units could be, and this could be anything you want. The left-hand side could be the research part of a university. The right-hand side could be the core IT side of the university. The OUs underneath could be individual departments or individual research projects. You're using the OUs as a mechanism to group together AWS accounts that have a similarity from an AWS use perspective. Because what you then have the ability to do is apply these what are called service control policies. So you can apply the service control policies either at an OU level or an individual account level. So if you apply it to, let's say, this OU here, the policy would apply to all of the accounts that exist underneath that level. The idea would be that if a particular project only needed access to a particular set of AWS services, you could limit the users in that particular group to the 10 AWS services that they needed, rather than the ability to spend on the entire 175 services plus portfolio. So it's another way in which you can control costs by providing this structure. At the top of this structure, there's something called a root account. So the other thing this does is brings consolidated billing to your organization. So it consolidates your AWS bill to the top of this structure. And this root account becomes a paying account for the accounts that exist underneath. So it's another mechanism via which you can, at the root level, you can write budgets for those underlying accounts. You will see Cost Explorer and dashboards for those accounts and what they've spent on the individual AWS services. So you get that element of control. So it's two things. It's consolidated billing and service control policies. What we then do is, and this is usually organizations and control towers and landing zones are usually the starting building blocks of building up a multi-account basis upon which you'll use AWS moving forwards. So you can see the AWS organization is inside what we refer to as a landing zone. What the landing zone does is provides that governance around those accounts and those organizational units. So it provides a set of guardrails. So it will tell you, for instance, if you're going to set up an S3 bucket and you haven't applied versioning to that bucket. It's a set of guardrails which allows you from day one to vend accounts. There's an account vending machine as part of this solution into a secure infrastructure managed, as part of an AWS organization with all of the controls and governance necessary to start your AWS journey. Now, you don't have to do this. You could arrive at this organically, but this is really the culmination of lots and lots of best practice from AWS. So our suggested starting point, both from a governance perspective and a cost control perspective, is to deploy a control tower based landing zone. The end-to-end process when you set up a landing zone is an automated process, and it takes, once we've hit the button to start the process, it takes about an hour to deploy everything you see in front of you. You're then in a position where you can vend accounts to their correct organizational unit in a fully governed environment. And that's the end of my slides.